Good morning to
Press
all.
start.
I feel privileged to extend my warm welcome to all the participants to the 2-week online certificate program on advanced logistics and supply chain management, innovating for the future. I request all the participants to mute their audio and video during the deliberation to avoid any type of technical problems. Thank you all. Today, to deliver the session on transportation and distribution management, we have with us Professor Shekhar Bellamkonda, who is the Pro Vice Chancellor of Central University of Hyderabad. Welcome you, sir. So let me briefly introduce Professor Shekhar sir to this session. Professor Shekhar is also currently the Dean of School of Management Studies, Director and Member Secretary of Internal Quality Assurance Cell at University of Hyderabad, has a commendable track record in field of higher education as an academic and academic administrator. He is associated with the School of Management Studies since its inception, that is June 1999. He is also coordinating in-house training programs of the university. Professor Shekhar has been coordinating postgraduate diploma in business management through Center of Distance and Virtual Learning for the past 12 years. Sir was associated with the Telangana State Public Service Commission as one of the members of the committee for formulation of scheme and syllabus. Professor Shekhar obtained his Bachelor of Technology degree in Civil Engineering and 3 master's degree in Business Administration, Psychology and Education. Professor Shekhar was awarded to 2 doctorate degrees in Business Management and Psychology. Added to above, he acquired 2 postgraduate diplomas in Personnel Management and Industrial Relations and Computer Science. Professor Shekhar also underwent a faculty development program at the Indian Institute of Management, Ahmedabad. Prior to joining the University of Hyderabad, he taught at Kakatiya University and Kamala Nehru Polytechnic for Women. Besides his academic activities, he served various administrative positions in the university, including Registrar, Dean Students Welfare, Chief Warden, etc. Professor Shekhar authored, edited and co-edited books in the areas of consumer protection, supply chain management and quality management. He has published 75 research papers in reputed international, national journals and conference proceedings. Professor Shekhar successfully guided 12 research scholars for PhD and 8 more scholars are working currently under his supervision. He is a specialist in the area of service quality and has been doing extensive research in various issues of service quality. He has been running a career counseling weekly column in a leading Telugu Daily newspaper, Inadu, titled Sandhenu Samadhanu. Professor Shekhar is actively engaged in research as a consultant and a principal investigator for DFID, FAO, UGC and AICT sponsored projects. Professor Shekhar is visiting faculty to various training institutions which include UGC, Human Resource Development Centers, National Institute of Rural Development and Panchayati Raj, National Institute of Pharmaceutical Education and Research, Dr. Mary Chana Reddy Human Resource Development Institute, Andhra Pradesh Human Resource Development Institute, National Institute of Agricultural Extension Management, National Academy of Agricultural Research Management, Indian Institute of Public Health, RBVRR Telangana State Policy Academy, Navodaya Leadership Institute, National Institute of Tourism and Hospitality Management, etc. He regularly delivers lectures in the areas of career planning, personality development at different graduate and postgraduate colleges and universities. His primary areas of interest include service quality, quantitative techniques, operations management, industrial and organizational psychology, and research methodology. I heartily welcome you, sir. Now I request Professor Shekhar sir to deliver the session.
Yeah, thank you, Professor Pratap. Are you able to hear me?
Yes, sir.
Okay, good. So very good morning to all the participants. Yeah, there are 18 participants now. Yeah. So
good morning, sir.
Good morning. Good morning. Good morning.
Good morning, sir.
Good morning. So we are now. I'm going to start the session now. So as you know, I'm going to speak something about transportation and distribution in supply chain management. Let me open my PowerPoint. Let me open my PowerPoint. Yes. Are you able to see the PowerPoint?
Yes, sir.
Okay, good.
Yes, sir.
Fine. So now what I am now trying to do, I am making my presentation into maybe two parts. One is PowerPoint, second one is Excel. So I wanted to discuss, I wanted to solve some of the problems of transportation by using MS Excel. I'll also try to show you. And before we get into Excel, we try to understand what is transportation and the distribution management in supply chain. I think
Sir,
for the
this
past,
transportation means it comes under logistics, no, sir?
yes, logistics only.
Okay, sir. Thank you.
Yeah, this is logistics only. Logistics and transportation.
Okay,
Yeah.
sir.
But the models what we are going to use are partly they are into operations research. The model what we use in operation transportation here also. Some of the operations research tools we use like traveling salesman problem, transshipment problem, routing problems. There we are going to use here in these transportation models also.
Okay, sir.
Okay. Yeah. So now it is not typical transportation what we do in operations research, but we use transportation models in supply chain management. Okay. So for that matter, you know, you find lot of overlap between operations research, operations management, and supply chain management because lot of things keep on moving. Say for example, I say inventory control. Inventory is part of OM, OR, and supply chain. Logistics also part of operations and supply chain. Right, and also there are routing problems also we discuss in OR, we discuss in OM, we discuss in supply chain. So I think, you know, we have a kind of a thin line, and one discuss about optimization, one discuss about process, one discuss about sustainability and so on. So here I'm going to discuss about transportation and distribution. Yeah, as you said, you know, I'm starting with logistics only. So it starts with the word itself. The first word of my first slide is logistics. So why logistics are very important? Logistics is very important in supply chain management. So the whole of supply chain management, if you look at what exactly happens in supply chain management, or even there are always kind of discussions and debates that, you know, why there should be a paper called supply chain management when everything is there in operations management. In operations management, we discuss a lot more things. But what is this so special about supply chain management? And most of the time, you know, the supply chain management is prefixed by logistics. It is logistics and supply chain management. So logistics is very important part of supply chain because the supply chains, when we speak about supply chains, we speak about the push strategy, we speak about the pull strategy, we speak about the efficient supply chains. We also speak about responsive supply chains. And now we know lean supply chain, green supply chain, and also we are speaking about supply chain, sustainability in supply chain. Okay. So then if you look at logistics, they basically what they do is they are moving the goods from suppliers to buyers. The first part is, you know, it moving the goods from suppliers to buyers. So how these goods are moved from suppliers to buyers? This is one part. So then move WIP, work in process, within the firm. So within the firm also, I think, you know, we need to move the WIP. Then move finished goods to the customer. Moving the finished goods to the customer. So that means, you know, this is next one, because the suppliers to buyers is some raw material. The raw material, we are now moving from suppliers to buyers. And once you start producing, the working process also will move within the firm. Then moving the finished goods to the customer. So once its product is manufactured, so then we are supposed to move from producer to customer. Then moving the returned goods back up upstream supply chain. So that is move returned goods back up. So that means we are now trying to returning the goods which are rejected, which are having repairs, which are supposed to be reworked, and so on. So the products have little value to the customer until they are moved to the customer's point of consumption. So products have little value to the customer until they are moved to the customer's point of consumption. Then what exactly the logistics are trying to do, that they are also trying to add some value to the products. And it is a time utility. Products are delivered at the right time. Place utility, products are delivered to the desired location. This is how I think we are understanding logistics. The logistics, it is more of the products are delivered at the right time. Products are delivered to the desired location. So how to move, where to move. These are the two important decisions we are going to make here.
Sir, sorry to interrupt, sir.
Please.
Prakash Dave sir is asking, terms transportation and logistics are same or different? If different, what is the difference between them?
Logistics is a whole and transportation is part of it. Logistics speak about even warehousing also. Warehousing also is part of logistics. Transportation speaks about only the moving. So I finally now, if you wanted to say what is logistics, we in operational terms, we say logistics is something to do with storing and moving. It speaks about storing and also in warehouses and so on, and it speaks about moving. The first part of logistics, why we have just started with that is, so since we are discussing the transportation part of logistics, that's where we started that. So that's where we are now trying to speak about transportation component in the logistics. So that is where we are trying to do that. When I am saying the moving goods from finished goods to the customer, it will not straight away move, because it will also have a lot of halts in between. It will not move, no item will move directly from manufacturer to the customer. It will have a lot of halts in between. It could be a distributor level, it could be a retailer level, and so on. So obviously that whenever it is stocking there, that is also comes under logistics. So that's where when we speak about moving from producer to customer, in between also it will have a lot of storing. So that is what actually the logistics will take care of both.
Okay, that means logistics is a broader term. Transportation is a part of logistics.
Correct.
Transportation comes from like where the goods are moved from suppliers to the manufacturers, or finished goods to the buyers.
Correct. And also in between it will also stay at several places.
Yeah.
So that's where if you look at the whole supply chain, the products, either they are staying in the warehouses or they are on the wheel. They are in the wheel in the sense they are in transit. So once the product is shipped from the manufacturer, either it will be staying at some place or either it will be moving on the move by road or rail or water, air, whatever. So this is a combination of these two. So the objectives of the logistics, if you look at, maximizing the value to the firm through price and delivery negotiations, provide profit contributions via cost reductions and better service. So if you look at why supply chain has gained a lot of importance, this is what I think we need to understand. The supply chain is about, I can say, 30 to 35-year-old subject. Maybe 1990 onwards, supply chain started gaining some importance. And especially around 2000, I think people started speaking more about supply chain. So why supply chain gained a lot of importance? Because people thought there are 2-3 important things in the whole criteria on which we are going to fix the price. One is the raw material procurement, price of the raw material and the procurement. Number 2 is processing and manufacturing. Number 3 is distribution, transportation, and other parts. So here, when you are trying to acquire the raw material from the suppliers, and also you would like to acquire from right quantity, right source, right quality, and so on, then, sometimes, you may not be able to have a much bargaining capacity. And as far as the production is concerned, though we have some of the operations management techniques like waste reduction, cost reduction, time reduction, but still, we may have to take care of all these things. Then what people thought is, the additional logistics cost, whatever we have, if you are able to reduce some of the cost there, so that is going to be a straight contributing to the profit of the organization. So that is where this logistics, it has got its own importance in the whole supply chain management. People are now looking at logistics as a profit center. That means, the logistics are, if you are efficiently manage logistics and you are able to make more and more money, cost reduction and so on. So that's where, and also the efficient logistics not only cut down the cost, it also enhances the customer satisfaction. So if you book a product through Amazon, that Amazon fellow says 3 days delivery, 3 days delivery, then you are mentally prepared to get that product for 3 days. But immediately on second day, you get a message stating that, we are delivering your product early. Then you are excited. So that is mostly because of efficient supply chains. Sometimes, I wanted to book the product through Amazon Prime. And today, if I book it, then, I'm supposed to get it in 24 hours because of I'm a Prime customer. But immediately today I have booked at night 8 o'clock and morning 7 o'clock or 7:30, the boy calls me, delivery boy calls me, sir, I have brought your product. So that exactly excites the customer. So here, that is also adding a lot of value to the firm through this kind of efficient management of logistics, and transportation, of course, is part of it. So through price and delivery negotiations, and also there are a lot of challenges in managing this transportation and logistics issues. And we are providing profit contributions via cost reductions and better service. There are two important things here. If you efficiently manage your logistics, there are two advantages. One is you are adding value through kind of a better service, and also you are reducing cost. That is another thing. And to make sure service is provided effectively. So we are now trying to provide the service effectively and satisfy the customer needs. And finally, what is the purpose of this whole transportation is to deliver at the right time, right place, right quantity in a way that it minimizes the cost. So the whole discussion of today, my discussion of today, is how to optimize the transportation facility, how to minimize the transportation cost. What are the challenges in managing the transportation cost? So what are the various issues we are going to have in this transportation? Because we have one manufacturing unit, but there are several distribution centers. So when we have multiple distribution centers, how these products can be transported, number one. Number two, what are the modes of transport? When we have multiple modes of transport, there are some are economical, there are some are kind of effective. Some are very quickly they can deliver, but very expensive. Some of them are taking its own time, but it will be delayed. So the cost will be less, but it will take longer time. Now I think we need to strike the balance between the efficiency, that is cost reduction, responsiveness, that is enhancing the customer service. So there is always a kind of a challenge between these two. So whether I should reach quickly or whether I should probably increase the cost or reduce the cost, then how do I segment my customers? That's what I think I was giving an example of Amazon. So there are some prime customers, they will get the things within 24 hours, and non-prime customers, it is not, I think you are unable to get it within 24 hours. But though you are a prime customer, you are not entitled to get everything within 24 hours. I think there's some of the things, if you wanted to put in non-prime, you get the product available, but the delivery time is 1 week or 10 days. If you select prime, then the product will vanish from your display. The reason is, they are unable to deliver. That means they also have a lot of mathematics behind it. Whether this product is worth delivering within 24 hours or can be delayed. Or is it, in spite of using all kind of efficient transportation, optimization techniques, whatever they have, whether they are able to deliver within 24 hours. If they want, they are able to deliver 24 hours, but that may cost them but the customer is not willing to share that extra cost. What customer wants is the product is supposed to be delivered within shortest possible time and at minimum possible price. This is also a customer always looks at. But unfortunately, if you wanted to do a speedy delivery, then your cost of delivery will be very high. But are we able to charge that kind of extra cost to the customer? If you are able to charge, it's a different story. But you are unable to charge. How do we club this kind of delivery with a routine delivery? But still, even if you club with the routine delivery, but how I am able to deliver the product on time, within the promised time. This is very important, because once you commit yourself that on so and so date I am going to deliver the product, and that has a lot of implications about the future relationship with you, with the customer, because how many times you are going to keep up your promise. That's going to be very important. So that's where this is going to play very important role. But in most of the times, people think it is after all transportation, but it is not after all transportation. Transportation has got its own relevance, and its own importance in especially supply chain management. So there are legal forms of transportation. Transportation service companies are classified legally as either common, contract, exempt, or private carriers. So common carriers, contract carriers. So here the common carriers are often transportation services to all shippers at published rates between designated locations without discrimination. So that means, there are some transportation service available, but at published rates between designated location without discrimination. But whereas the contract carriers are concerned, not bound to serve the general public, contract carriers serve the specific customers under contractual agreements. So that means you are now trying to hire a particular facility for yourself, and you are using a kind of a common facility. Then if you look at exempt carriers, exempt from regulation of services rates if they transport certain exempt products like produce, livestock, coal, or newspapers. I think there are some kind of carriers, because the government has regulations that you are having some kind of a exemption from regulation of services and rates if they transport certain exempt products like produce, livestock. And the private carrier are not subject to economic regulation and typically transports goods for the company owning the carrier. The company is having its own carrier. So there are four kinds of things now we could see. So one is common carrier. Second one is contract carrier. Contract carrier is though that fellow is working for you but not owned by you. And the common carrier is not owned by you, but it is also not only your product, that fellow can carry others also. Whereas in the contract carriers, that fellow carry only yours, but the vehicle is not owned by you. And it's exempt carriers, the regulation of services rates, and if they transport certain exempt products, they are exempted. And the private carrier is not subjected to economic regulation, and they typically transport goods for the company owning the carrier. The company itself is having its own carrier. So finally, if you look at this transportation functionality, provides two major functions. So one is the product movement, and second one is the product storage. So functions of transportation. This is the thin line between the transportation logistics, because it is also now, if you look at the second part, the product storage. It is now, if we are saying about the functionality, transport functionality. What is the functionality of the transport? Is it facilitates movement, it facilitates storage. This is what it is. It facilitates storage. It facilitates. So these are the two major functions of transportation. The first one is, if you look at the product movement. So here the product is locked up during the transit. Hence, it is inaccessible. That is called in-transit inventory. Positive amount of time is spent in transporting material. Time is a resource, it's a temporal resource expended in transportation. During the time product is locked up, costs are incurred in the proportion of time. So there is also some opportunity cost associated with that. Then financial is administration cost, salaries, maintenance cost are expended. The environmental is the fuel cost are high, creates air pollution, congestion, noise pollution. So when I was speaking about this sustainable supply chain management, there we are trying to look at three important kind of benefits out of sustainable supply chain management. One is economic benefit, second one is social benefit, Third one is environmental benefit. So this is environmental consequences of your product movement. When you are transporting goods and services from one place to other place, it is also a threat to environment. Though you are delivering the products on time and everything is fine, but how much I think the fuel, your pollution, and you are responsible for congestion and noise pollution and etc. And the administration cost, salaries, maintenance cost are all financial. And the temporal is, it's a kind of a loss. The time is one resource, and you are going to do that. And also the time, during the time the product is locked up, costs are incurred in proportion of time. Then when unloading and loading is more expensive than storage. So this is also a very important issue. So product storage, when you are speaking of product storage, when unloading and loading, sometimes when you wanted to store the product, you wanted to load it and unload it. When storage space is limited, that is also another kind of a problem. So the storage space is very much limited, then the storage cost is also going to increase. So sometimes what happens, there is a situation where you are supposed to stock the product in the warehouse, but since warehouse has no vacancy to accommodate these things, then you are still stocking the vehicle in the truck itself. The truck is supposed to dump the material and go back, but it happens so that some of the people are supposed to come for the delivery of the product. They have not come and they are unable to deliver because the concerned person was supposed to deliver and he is not there, or the vehicle which is supposed to come and pick up, or it is not there, or even somebody has placed the order and in anticipation of disposal of the stock, you have planned to stock the extra new items, whatever you are going to get, but meanwhile that customer has cancelled the order. If the customer has cancelled the order, by the time you wanted to revise, then already the product is shipped from your source. So the product is in transit. Then product comes to your warehouse and your warehouse has no kind of vacancy, no space. Then you keep the truck waiting till you find an alternative arrangement. Till that time you are going to incur the cost on the transportation. This is another kind of a challenge. There are two fundamental principles guiding transportation management and operations. So one is economy of scale. The second one is economy of distance. So if you look at the entire transportation, there are two important challenges we are trying to ask. One is how much quantity each shipment can have, number one. And also, what is the kind of a load distance we are trying to calculate? Load distance, especially I think in looking at again sustainable supply chain, we are trying to speak about food miles. Food mile means before it reaches the customer, how many food miles a unit of product is going to travel. So the food miles are going to be more, then the environmental consequences and other consequences and cost associated can be more. But to avoid that problem, to avoid or to minimize those distances to be traveled, and if you may not be able to afford to start many units where you are going to manufacture. So then you have only one or two manufacturing units, and you may not have 100 manufacturing units. And then next we need to have some kind of warehouses. Warehouses are sometimes owned by the company. Warehouses are owned by the distributors, retailers, and whatever. Or sometimes there should be a third party stocking your logistics. That is the 3PL, third party logistics. We are now trying to speak about. But here, the principles of transportation, we are trying to look at two important things. Okay, one is economy of scale. Second one is economy of distance. Here, if you look at economy of scale, it refers to the characteristic that transportation cost per unit of the weight decreases when the size of the shipment increases. This is a kind of a very common principle, because when you have hired a kind of a truck for your own purpose and you are going to pay some X amount, and whatever quantity you are going to transport, that per unit transportation cost is X by N. So as N increases, then obviously that per unit transportation cost will come down. But most of the time what happens is the quantity what we are supposed to deliver may not be sufficient enough for a one full truck load. Then what are we supposed to do? And it may be more than a smaller truck and lesser than for a bigger truck. Then how do we decide? the size of the truck. So then what are the other kinds of options? The next option could be, shall we club 2-3 kind of orders and 2-3 kinds of locations and try to do that. The consequence, what is going to happen now? So it may take a little longer time, and transportation wise it is going to be viable, but time wise it may not be viable, because the same truck, instead of having 2 trucks going to 2 locations, you are making 1 truck to go to 2 or 3 locations. So when you are going for a optimum utilization of resources like trucks and other things, so shipment when you are trying to think of, then what is happening is, it is more of, if you have too many trucks, then your efficiency is very high in terms of delivery, but your expenses are more. You have a single truck and trying to reach 5 to 6 locations, then it will take its own time. By the time it goes to the 6th location, you may not be fulfilling the promises whatever you have made to your customers. Now, the next important question is, how many ideal number of trucks we should use to transport this material. Here, the transportation cost per unit of weight decreases when the size of the shipment increases. For example, truckload shipments, that is shipments that utilize the vehicle's capacity, cost less per rupees than less than truckload, LTL. That means, my truck capacity is somewhere around some 1 ton, and if you only able to send 50%, half ton, then obviously this half ton is going to cost, we have to pay for the transportation cost for full truck, but we are transporting only half truck. But instead, if you transport full truck, then your cost of transport will come down. This is where it is called a TL and LTL. TL stands for truckload, LTL stands for less than truckload. Then economy of distance refers to the characteristic that transportation cost per unit of distance decreases as the distance increases. So this is like a bus ticket. Bus ticket, if you go from city 1 to city 2, you pay some money, and if you divide the total money you have paid divided by number of kilometers traveled, that you get some money. And you just take one more place, your native place to your nearby town, the distance may be 25 kilometers and you may be paying some 30 rupees. Then the ratio between per kilometer, you may be paying 1 rupee if it is a short distance. And if it's a long distance, per kilometer, you may be paying maybe some 80 paisa, 70 paisa, 60 paisa. This is like a train journey. So with 1 hour journey, you may pay X, and with 24 hours journey, you are not going to pay 24X. You are going to pay only 10X or 12X. So because more the distance you travel, then obviously the transportation cost per unit of distance decreases. I think now we need to move around these 2 things, economy of scale and economy of distance. The transportation economy of distance is also referred as the tapering principle, since the rate of charges taper with the distance. As the distance increases, the prices are going to come down. Per unit transportation cost is going to come down. So, but at the same time, if you are going to hire a vehicle to transport for the longer distances, may be economical, but it will take longer time. So these principles are important. The A is missing. Are important the considerations when evaluating alternative transportation strategies or operating practices. I think these are the kind of decisions we are supposed to make. This analysis and these inputs are going to be useful when you are evaluating the alternative transportation methods. So who are all these transport participants? So I think shipper, consignee, receiver, the carrier agents, the government, public, and of course internet is it's a kind of an invisible thing where the information flows. It is going to coordinate everything. The internet providers are internet people who are handling that IT. So they are the people. Of course, government regulations are going to, and the carrier agents, and the public is also finally is going to have a direct or indirect impact with your transport. So I think the transport is not that such a small topic. What we just we say that what is there in transport, it is only just moving the items, but it has got lot of science and lot of important consequences. Then before we proceed further, let us just quickly discuss about various modes of transport and discuss about its advantages and disadvantages. So let us start with rail. I think most of the things you are also aware. So advantages of a rail transport is it is convenient mode of transport for traveling long distances. Then it is relatively faster than road transport. For example, from here to Delhi, if I wanted to transport something by train, it takes 24 hours, but by road it will take longer time. And also, relatively it is cheaper when compared to hiring a truck. It is suitable for carrying heavy goods in large quantities over long distances. Its operation is less affected by adverse weather conditions like rain, floods, fog, etc. Because why it is specifically mentioned is when it is a flood or rain, but also some of the rail transport also not, we can't say that totally not affected by floods. Sometimes there may be possibility, but still when compared to other modes of transport, I think it is all relative comparison. It is not an absolute way of saying it. The limitations are relatively expensive for carrying goods and passengers over short distances. It may be good for the longer distances, not necessarily good for the shorter distances. It is not available in remote parts of the country because especially if you go to northeastern states, most of the northeastern states are not connected, locations are not connected by train. So this is kind of one limitation. It provides service according to fixed time schedule and is not flexible for loading or unloading of goods at any place. So that means there is the fixed schedules are there, and you may have to adjust your delivery according to their schedule. It is not like that hiring a truck and sending it as and when you feel. If you wanted to send the material by truck, so within no time you can fix it and send it. But as far as this is concerned, for example, there are some kind of places where the train is available, the goods train is available only once in a week. So definitely you may have to wait till that week, but it may not cannot happen just like that. So it provides service according to fixed time schedule. And of course, it involves heavy losses of life as well as goods in case of accident. So this is one kind of a challenge when there is some accident takes place. I think the opportunity, actual loss or opportunity loss can be very high. So because of it is carrying too much of load. So one train is equal to some 40, 50, 60, 70 or 100 trucks. Then obviously, if the truck accident takes place, only one truck material is spoiled. But if it is a train accident takes place, I think several tons of material will be wasted. But then again, also we can say the probability of a train accident and the probability of truck accident. The probability of train accidents are low when compared to probability of truck accident. The second kind of a transport is the road transport. Here, it is the relatively cheaper mode of transport as compared to other modes. Again, subjected to distance. Perishable goods can be transported at a faster speed by road carriers over a short distance. So this is like perishable goods. For example, vegetables I am supposed to transport. I think to transport vegetables, the road is better mode of transport than air or maybe the rail. Okay, the perishable goods. Even sometimes whatever milk, it could be fish, it could be meat, whatever. So I think the fruits, perishable goods can be transported at a faster speed by road carriers over a short distance. It is flexible mode of transport. Loading and unloading is possible at any destination. It provides door-to-door service. This is another advantage is, if you compare with the rail, I think people have to go to the railway station and pick up. But whereas here, the truck can come to your warehouse and deliver here only. So it is also possible door-to-door. And also the railway stations may not be there at every place, but this, as long as there is a route is available, road is available, the truck can go and by road they can deliver. It helps people to travel and carry goods from one place to another in places which are not connected by other means of transport, like hilly areas. That's what I was giving, like Northeast and so on. The limitations of road transport is due to limited carrying capacity, road transport is not economical for long distance transportation of goods. So then the transportation of heavy goods or goods in bulk by road involves high cost. So heavy goods or goods in bulk by road involves high cost. So this is also kind of because sometimes we see on the road transport some kind of boilers with 30, 40, 60, 70 tires vehicle. So it will go. Sometimes what happens is the road condition is so bad and that such kind of a heavy vehicle is not permitted on certain roads. Then you have to take long route. Sometimes with such kind of a load you cannot travel in hilly areas because it's difficult to. Then we need to have high-end vehicles which could be very expensive. Then the next one is water transport. It is relatively economical mode of transport for bulky and heavy goods. It is safe mode of transport with respect to occurrence of accidents. The cost of maintaining and constructing routes is very low. Most of them are naturally made. It promotes international trade. It is through mostly shipping. The disadvantages are the depth and navigability of rivers and canals vary and thus affect operations of different transport vessels. This is also another important because sometimes when we speak about water transport, it need not be always through sea. It could be also through canal. It is a slow-moving mode of transport and therefore not suitable for transport of perishable goods. It will take its own time, 3 months, 2 months, especially when it is a inter-country travel. It is adversely affected by weather conditions. That is also there. The sea transport requires large investment on ships and their maintenance. This is also another kind of a challenge. But each method has got its own mode of transport, has got its own advantage and disadvantage. Then look at the air transport. It is fastest mode of transport, as all of us know. It is very useful in transporting goods and passengers to the area which are not accessible by any other means. It is also possible because like helicopters are possible. We can go and dump at any stage. And it is the most convenient mode of transport during the natural calamities. That's what I think most of the floods and earthquakes when we have. This is only the way the trains cannot go, buses cannot go. There may not be a possibility for ship everywhere, water transport. It provides vital support to the national security and defense, of course. The disadvantages are, it is relatively more expensive mode of transport. It is not suitable for transporting heavy and bulky goods because of the restrictions of the weight and other things. It is affected by adverse weather conditions that also we experience. It is not suitable for short distance travel. In case of accidents, it results in heavy losses of goods, property, and life. I think, now we have this 4 varieties, and the last one is pipeline transport, and that is only restricted to gas and petrol and gas. And probably if you wanted to even consider water to be transported, that is also another kind of an option, pipeline. But it has got very, very limited kind of a. So whatever now we have discussed so far, so everything is consolidated in one particular sheet. So here, rail, road, water, air, pipeline. I think, these are the 5 things are compared. The price, if you look at how it's going to happen, rail is low, pipeline is very low, water is very low, road is high, air is very high. Speed, if you look at, the very high, air is very fast, and water is very slow, pipeline is slow, road is fast, and rail is slow. Door, and it is rail is sometimes, of course, in speed rail, if you say short distance, long distance, also we need to take into consideration. For long distance, the rail speed is fast, road speed is less. The door delivery, it is sometimes yes, road yes, water sometimes, air no, pipeline sometimes. Because sometimes the gas is delivered to the domestic houses also. Reliability is very high in air because if you promise something, you are able to deliver it. That's where most of the courier services, there's something called Blue Dart or DHL and the first flight courier. I think mostly they operate through flight, and that's where the reliability of their delivery is very, very high. Then pipeline also very high unless there is a leakage between, and railroad is medium, water is low. Packaging needs. So water requires high packaging need. Pipeline, there is no requirement of package. Rail requires good high packaging. The air may not have such kind of a packaging kind of a restriction, but road medium packaging. The risk of loss of damage. High is rail and very low in pipeline, medium in other places, and then flexibility. So high is road. Road is very high. High, I think very high, I can say. Air is very low and pipeline is very low. The environmental impact is pipeline is low and water is low, and the road is high, rail is low, air is medium. I think now the particular picture is going to give you a kind of an understanding of all modes of transport. Now my question is, you have some quantity to be shipped, and you have all varieties of customers. You have all varieties of customers who want quick delivery, who can wait, and who wanted to pay more, who cannot pay more. and some of your products are fit for delivering by air, some of them are not fit for delivering by air. All these combinations are there. So now our optimization comes into picture here. Now I have some X quantity to be shipped to several people. Now I need to choose what is the optimum mix of all these modes of transport. Optimum mix of modes of transport, and how to allocate the quantities to each mode of transport by keeping all these parameters. By keeping all these parameters, whether it is price, whether it is speed, whether it is door, whether reliability, packaging needs, risk of loss and damage, flexibility, environmental impact, and everything. So I think based on these, and some of the customers are highly environment conscious. They say that no, my product should have traveled, should have shipped, should have distributed through environmental friendly way. There are some people insist for it. Then I think we need to take that into consideration. In the similar way, somebody wanted to pay insurance. I think who should pay insurance? Whether sometimes in transit something goes wrong, I have to pay insurance. But the insurance premium also varies from each mode of transport, and I need to look at what is the profit I am going to make out of it, what is the insurance premium I am going to make out of it, and what are the chances that I may lose this particular product, and so on. So how do we handle such kind of a thing? So then the factors influencing transportation cost, that is transportation cost per unit load, is volume. Higher the volume will reduce per unit cost of transportation. Distance, as we have discussed, higher the distance, higher the cost. Product density, weight per unit volume, weight per unit volume. So that is also very important. Then product shape, odd size of products may need towing because even size, odd size, and then product handling, specific requirement for loading and unloading. Then product type and nature, insulated or air conditioned. Sometimes I require some products or should be I think transported under air conditioned situation. So for one example, such example I can give you is if you wanted to transport the milk from one place to other place, I need to probably do in a kind of refrigerated kind of a situation. Otherwise, it may be difficult for me to transport. Either it could be milk, it could be fish, it could be meat, or it could be even cooked items, whatever. So I think how we are going to do that, and of course the market dynamic conditions and the demand and the supply conditions. Sometimes what happens is your competitors are having an efficient transport mechanism to compete the transportation, whether we like it or not. We may have to get into that, otherwise you may lose that huge market. So finally, what I wanted to say, the strength of the supply chain mostly dependent on the strength of your transportation and distribution mechanism. So all other things are important, not that I am not saying they are not important, but the efficiency of the transportation significantly influences the efficiency and the performance of supply chain. That's what I wanted to say. So based on these parameters, we need to make some kind of decision. And here, the factors affecting transport decisions, what kind of decisions we are trying to take. Number one is carrier decision. Carrier decision. The party that moves or transports the product. One is vehicle related cost, whatever vehicle mode of transport, fixed operating cost, and trip related cost, trip related cost. Then the shipper, the party that requires the movement of the product between 2 points in the supply chain. That is transportation cost, inventory cost, and facility cost. So that party which requires movement of the product between 2 points in the supply chain, that is called shipper. So here, the transportation cost, inventory cost, and facility cost. And what is the risk in management in transportation? Three main risks in transportation are delayed shipment. This is what I think I have been discussing. Number one is disruptions. Number three is hazardous material. Hazardous material like petrol. We are now transporting petrol. Or sometimes it could be alcohol. So some kind of acids. So there are kinds of risk, and when you are transporting such kind of items, I think you need to have special permissions. And also if something somewhere goes wrong, we can see some of the cars and bikes also when they hit a container which is carrying some petrol or diesel or maybe some alcohol or some other acid. I think they are died because of this fire what takes place because of this accident with that kind of a material what is inside. So that is a hazardous material. The risk mitigation strategies are decrease the probability of disruptions. So as long as they are under your control, you can minimize those disruptions. Then alternative routings. So instead of using the same route, sometimes if you go to one route, you are quickly able to deliver, but the chances of probability of hitting I think can be more. That's what I always experience when I go to Pondicherry from Chennai. So they will say there are two routes. One is via Trichy route, and while going to Trichy, we need to take a turn and go to Pondicherry. The second route is ECR, East Coast Road. People say ECR you can go very fast, but there is a probability of accidents. And if you go via the Trichy road, I think it may take a longer time, but chances of accidents are very low. So like that, in our transportation also, we have this kind of a scenario. So that also we need to keep, or maybe what component you are trying to send through one route and what percentage of your content or component you are going to shipment, your containment you are going to send to other route, alternative routings. Then proper packaging and containerization. So how you are going to do that packaging, because packaging is very, very important. How this packaging is going to help and how this packaging, because the better package, sometimes, the product is made properly, but because of the in transit, when you are transporting the things, the product gets damaged in the transport, then how do we have? Sometimes your package is bad because of the poor package. I think, when you are downloading or uploading, when you are now, I think, then also, I think there is a kind of, when you are taking away the product from the vehicle or when you are able to put it to the vehicle, so it is going to get damaged. So that is also proper packaging and containerization. It's also very important. So the transport decisions in practice align transportation strategy with the competitive strategy. So this is as good as, the transportation strategy also plays very important, but it should align with the competitive strategy. Consider both in-house and outsourced transportation. This is always a kind of a discussion, whether the entire transport should be outsourced or the entire transport should be insourced, or there should be a proper mix of both. But then if you have a mix of both, then what is the proportion of in-house transportation material content, and outhouse, what quantity you are going to keep it for in-house, what quantity you are going to keep outsource. Then also we are trying to look at, for which areas you are going for in-source, or which areas you are going for outsource. Then use technology to improve transportation performance. So that is one thing is tracking of the vehicles, and also using little more kind of a GPS kind of a technique to know, and maybe tracing the vehicle, tracking the vehicle. I think these are the important things. Design flexibility into the transportation network. So when you are making so you may not be having very rigid, and you need to have a flexibility into the transportation network, so that you can also change your strategy based on the situation. So this is where, sometimes, if you go further details of this transportation, and the safety of the driver also plays very important, and the safe driving. So how do we ensure that your drivers, especially when you are using the road transport, so they are safely driving the vehicles? And how do we ensure that, these drivers are not consuming alcohol when they are driving the vehicle? How do we ensure that these drivers are not halting their vehicle and they are not moving at all? Sometimes also whether these drivers are getting enough rest or not. How do we ensure that? I think these are also, though it looks simple, but it's also very important. That's where Walmart has a policy for their transport and logistics department. There, they specifically mentioned that number one, any driver who is getting into Walmart, I think they should have several thousands of miles of driving experience without accident. I think such kind of qualification. Also, there are some mandatory rest, whether you like it or not. Beyond these many hours, a driver is not supposed to drive the vehicle. So it's all the precautions which will minimize the probability of committing accidents, probability of committing other kind of issues. That's where and also the vehicle conditioning, vehicle servicing, the quality of vehicle, the maintenance of the vehicle, preventive maintenance of the vehicle, and what kind of technical support you have to maintain the vehicles. All these things are very, very important when you are trying to discuss about the transportation. Then we are now trying to understand what are these kind of a transportation networks. So here there are point-to-point network, point-to-point network. Second one is multiple delivery points. I think once you start the product and it goes to a point and deliver, it is a point-to-point network. Multiple delivery points. I think the items are delivered at multiple places. Transshipment points. Then nodal network. Nodal network. That is a transshipment point it is a source as well as a destination. So whereas in multiple delivery points, it is only a destination, multiple destinations. But in transshipment problem, it is a multiple source and multiple destination. That means each source will act as a destination, each destination will act as a source. Then nodal network. We have a nodal network and hub and spoke network. So we have a hub and all the spokes we are trying to do that. So transportation network, point to point, multiple delivery points, transshipment, nodal network, hub and spoke network. So right. Then the typical transport decisions, what exactly we are now. So far, I have given you a lot of theory. So with this theory, now we are getting into the operational part of it. So now let us see the mode of service selection. So how do we select? So the private fleet planning, carrier routing from multiple points, routing from coincident origin and destination points, vehicle routing and scheduling. I think these are the various kind of things we are trying to understand, and also the freight consolidation, how this freight can be consolidated. So now we are trying to identify the mode and the service selection. See, for example, let me take one kind of an example. The problem is how to identify the mode of selection. Then again, I can go for a one mode or multiple modes. First one, if I go for one mode, out of given modes, I think, for example, I have air, truck, rail. Then three options are there. Out of three options, which option I am supposed to choose? This is number one. One is, I choose only one option. The second option is, no, it's one option is not viable, choose all three options. Then when I say choose all the three options, the next important question is, what is the proportion? 30, 40, 30, 50, 25, 25, 50, 10, 40, whatever. This could be multiple combinations. This is a kind of an outcome we are going to expect. Then methods of, then define the available choices. Then balance performance effects on inventory against the cost of transport. Because here also you remember, for example, I am delivering the whole train load at one place. It would be economical as far as transport is concerned. But the inventory cost can be more because all the material should go and I need to find out a place to stock the kind of a whole train load of the material. Then you may be saving on the transport, but you are incurring on inventory. But if you use the road transport, you may be spending more on the road transport, but you may be saving on the inventory. But sometimes, there is enough demand and whatever you just maybe transport, everything is going to be consumed on the same day without getting into inventory, that is valid. But sometimes invariably some items are going to stay in inventory, warehouse, for example, warehouse. Then what are the associated costs there? Because even there loading and unloading, that is another important aspect. You have to load and unload and moving from. Sometimes what will happen, there is a combination. Because from point to point, you may not have one single transport. For some distance, it has to go by maybe air. From there, it has to go by train. From train, it has to go by road. I think, there is no either air connection or rail connection or road connection. So I have a combination of all the three. So that means in the same quantity of material, it has to move from one mode of transport to other mode of transport. How do we handle that kind of a situation? And sometimes also, when we are speaking about the transport, because we are also logistics, when we are trying to discuss about it, we are also trying to say something about the storage, inventory, warehouse. Then what would be the location, strategic location of warehouse? At various locations, we are going to construct the warehouses, and then we have a lot of mathematics behind it, and we need to identify our warehouses strategically. So if you look at in a global supply chain, the people are having warehouses of various countries either in Singapore or Malaysia or Dubai. They are having, strategically they are having their warehouses at those places, so that they are highly connected by air to multiple places, and now they would like to transport from them. That is the strategic location. I am now speaking about a global supply chain, but within the nation supply chain also, local supply chains or nation supply chain also, we need to identify what are the various strategic locations for our warehouses. That is also another important decision we are supposed to make. But right now, I am mostly working on the transport decision. So here, the methods of selection, indirectly through network configuration, directly through channel simulation, and directly through a spreadsheet approach as follows. So sometimes there is a indirectly through network configuration, we are trying to identify how it works out, or through channel simulation. We are now trying to run the simulation. I think without actually transporting the material. Now I will do a kind of a simulation mode. If I do transport this quantity by this mode of transport, what will be the expenditure? Like that, I keep on changing the combinations, and finally, as and when I receive, I get an optimal kind of answer. Then I say that this is the right mix. Then the other kinds of data, whatever you look at, is the cost type, air, truck rate, and basically transportation, in-transit inventory, source inventory, destination inventory. I think these kind of things we are trying to get, and based on that we are trying to make some decision. Now I will give you one simple example here. One example you can understand. A finished goods are to be shipped from a plant inventory to a warehouse inventory some distance away. The expected volume to be shipped in a year is 12 lakh pounds. The product is worth $25 per pound, and the plant and carrying cost are 30% per year. And other data they have given, this is a rail, $0.11 per pound, truck $0.20 per pound, air $0.88 per pound. Transit time, rail will take 25 days, truck will take 30 days, air will take 1 day. The shipment size, rail can take 1 lakh, truck can take 40,000, air can take I think 16,000. Now if you just transfer this information to a simple Excel sheet. Now if it is 1 lakh and it is 12 lakhs, the product is worth of $25 per LB. Whether it is you are transporting by road or ship or anything, that price is going to be same, $25 per unit, but that is independent of your mode of transport. But the plant and carrying cost are 30% per year. So now this is inventory is one important issue. So this is going to decide your kind of a carrying cost or holding cost in the inventory, that is 30%. So if you stock more, your inventory cost is going to increase. If you stock less, your transportation cost is going to increase. So now we need to strike the balance between your transportation cost and your carrying or the holding cost. So if you use the rail, and you may have to use 12 shipments. Shipment size is 1 lakh for the rail. I need to use maybe 12 shipments. If it is a truck, so here it is going to be 30 shipments, because 40,000 multiplied by 30, it is going to be 12,000. So 30 shipments I am supposed to use. If it is going to be air, I think 1200 by 6. So that is around 75 shipments of air I am supposed to use. So and also per unit transportation cost, you have to multiply 0.88 into 12 lakhs, 0.20 into 12 lakhs, 0.11 into 12 lakhs. And the capacities are given here. And fortunately, there is no restriction on number of shipments you are allowed. Even if I wanted to transport everything by air, but that the airline say it is not possible beyond this capacity, you cannot, because we have only these many flights available to transport your material. So though you wanted to have 75, but they will put a restriction that not more than 25 you can transport, or sometimes unlimited. We don't know. Trucks also, when I'm going for 40,000, I require 30. But whether 30 trucks are available or not is a question. Or they may say you cannot use any point in time more than 20 trucks. So only 20 trucks we are supposed to use to transport this 40 or 12 lakhs, but not beyond that. The similar way rail also, I require 12 kinds of opportunity shipments, but they say that not more than 6 you can use. So that means I am going to add one more extra constraint, one more thing. What would be the possible shipments restriction? But fortunately, in this case, we are not bothering about the number of kind of a restriction on number of shipments. So with this, now I wanted to proceed. So then what I do now, quickly, I will open my Excel sheet. Are you able to see the Excel sheet, or still you are seeing the PowerPoint?
Excel sheet, sir.
Now you are able to see the Excel sheet?
Yes, sir.
Okay, good. Now with this Excel sheet, now just let me do some small exercise and I will tell you how we can go. So for example, we have rail. Then we have truck and air. Here, 0.11, 0.11, 0.20, 0.88, 0.20, 0.18, 25, 13, 1, 25, 13, 1, 25, 13, 1, and 1,40,000, 16,000, 1,40,000, 16,000. Fine. The total availability we are not supposed to do is 12 lakhs LB. 12 lakhs LB. Then the price is $25 and the carrying cost is 30%. This is the data. I think I have almost transferred the whole data. Fine. Now this is the data available. This is the mode of transport. Then if you look at this, rate, time, this is rate. This is rate per LB. Rate per LB. Then it is a days to transport. This is shipment. Now this is the problem given to you. This is the data given to you. So by rail, and I'm supposed to transport 12 lakh items. 12 lakh items. For our understanding, yeah, I'm putting commas. 12 lakhs items here. Yeah, 1,40,000, 16,000. Days 25, 31. And we are supposed to make the decision. And it is the holding cost or carrying cost. Whatever. Holding cost. Okay. This is the holding cost. This is this 25 is product worth. Now, this is the per year volume per year. Now we are also doing for only 1 year. Volume per year. This is the data now we have with us. Now I am supposed to solve it. So for example, number of shipments. I am now number of shipments. Number of shipments is equal is 12 lakhs by 1 lakh. Since I am going to fix this 12 lakhs, press F4. So that it will be fixed. So this is 12 shipments. If I click this, 30 shipments and 75 shipments. So here the load days, 25 days and also rate for LB. I think rate for shipment. Rate for shipment. If you look at here, per shipment rate I am calculating. That is 0.11 into 1 lakh. 0.11 into. Now we are now trying to multiply 0.11 into 1 lakh. So it is 11 lakh. So it is 8,000. This is 4080 rate for shipment. So if I multiply total cost here, each shipment is 11,000 multiplied by 12 here. So now you can see. So to shift all 12 lakhs, it is 1,32,000. Truck 2,40,000. Air 10,56,000. But here is 25 days, 13 days, 1 day. So now I am trying to concentrate on days. So it is 25 days, it is 13 days, it is 1 day. For 25 days it is 1,32,000. 13 days it is going to be 240. And also this 25 days, now some more information is not available. Is it possible to ship all 12 on same day? No, it is not correct. So what is that now I am assuming here? The demand is uniformly distributed. So the total volume is 12 lakhs. Total volume is 12 lakhs. But now I wanted to bring down to maybe I'll make it as 1 lakh. So because the 12 lakhs divided by 12, so it is going to be monthly one. So 1 lakh. So even if you divide by 112, so the shipments are 1 here, truck 2.5, air 6.25. And this is the transportation cost, 10,000, 20,000, 88,000. So what is that now I'm supposed to do? And also days 25, 13, 1. And we don't have some other information that how many customers require delivery within a day, how many customers can require maybe 13 days they can wait, and how many people can wait for 25 days. This is also very important, the willingness for the customer to wait. Since the data is not provided here, I'm assuming that 0.33 people, they wanted to, I think, prefer quick delivery. So then, for example, 33% of the people are, that people in the sense content, quantity, 33% of the quantity can probably go for rail, 33% go for truck, 33% for air. It all depends on our demand. So whatever is our demand we have. So because some people would like to have it very quickly, some people would like to have it leisurely. So 33. So that means what we are now trying to do, 33,333. This is the quantities we are going to transport. 33,333. Now I am only working for a month. Later we can multiply with the 12 months. So I am just trying to reduce it. So in a month, we are trying to do 33,000, 33,000. So we have these three quantities, 33, because these people can wait for 25 days. These people can wait for 13 days. These people can wait for 1 day. Then if you go for this shipment, how many shipments we are going to use? Or otherwise I don't want to have the shipments. Straight away I will calculate this into this 0.11. So 3666 and it is 666, 6066, and if I take the total cost is 39,666.27. Okay. So provided if the customers are willing to wait for 25 days, 13 days and 1 day. But assuming that again, the consumption of this would be this 33,333 also, whether it is uniformly consumed or consumed in kind of a batches. That information is not available. The next problem is, for example, you are going by air. I'm getting some disturbance. I'm getting some disturbance. Yeah. So when you are going by this air, 33,333, you are charging 29,333. But you know, if everything is delivered on same day, no issue. Otherwise, what will happen now? You have delivered in one day there. Then from there, it is going to be there for again some days in the inventory. Some days in the inventory. Now inventory cost is 30%. 30%. So 30% is the inventory cost. So we need to also include that 30% inventory cost. But here we don't know because it is 25 days. So 25 days means it will wait in the inventory only 5 days. Because you know, if I deliver on this month first, it will go on 25th. So then it will wait for 5 days. Because assuming that my requirement is the next month first. And also I have to do it 13 days before. 13 days before I should deliver. And 1 day before I should deliver. That means my requirement is from August 1st. So July 31st, I am going to transport by air. 13 days before August 1st by truck. 25 days before, I would like to do it by rail. So then all of them would be arriving on the same day. All of them would be arriving on the same day. But again, there is a kind of a, I say 33,333, 33,333, 30,333. So all of them have come on the same day. All of them have come on the same day. But all of them are going to inventory now. And this is being distributed. We don't know. Again, they have not given data. So we assume that the initial inventory is 1 lakh on the day 1. This is also an assumption I am making. And the last day it is going to be 0. So that means that the demand is uniform. Then my average inventory is 50,000. My average inventory is 50,000 because I'm taking the maxima plus minima by 2. So this I am now trying to multiply with my $25 multiplied by 30%. Multiplied by 30%. 30%. So this is going to be my inventory cost because it is 25 worth 30% of it is going to be holding cost. So this is my holding cost. This is my holding cost. Now the total cost is this plus is equal. Now it is equal this plus 37,500. This if you multiply with the 12. So this are just decimals I can ignore. Yeah. And if I put comma. So 49,75,995. What is this? This is only a holding cost plus transport cost. This is a holding cost plus transport cost is 49,75,995. Okay. So here I am now writing here the assumption of one third each. One third each. So my total cost is 49,75,995. 40,975,995. Now here I am changing this to 50% of them are willing to do by rail, 25% of them are willing to do by truck, 25% of them are willing to do by air. So this is one. So then if that is the case, here you multiply your 1 lakh multiplied by this 0.5, 50,000. So then what happened now? This 1 lakh is anyway, the assumption is 1 lakh per month. So that's why it is not changed. So it is 48 lakh. So now this is option 1. First option. Okay. FO1. Option 1, we can say simply. Option 1. Then option 2, is going to be, what is this? 0.5 east, 0.5 east, 0.25 east, 0.25. So this is going to be 48,90,000. So this is second option. Now you can go for the third option here. So simply by changing this, I think 70% they are willing to go for train, and 20% they are going to willing for truck, and it is 0.1% they're going to. Now for your information, let me also put a total here. Editing, auto sum, yes, 1. So then accordingly 70,000, 20,000, 10,000 and 77. But what happened here? Again, now I will get back to you. There is also a kind of a problem here. Here the problem is, though you are paying 70,000, but you have to pay for 1 lakh. This is another kind of a problem. It is not up to 1 lakh. So then the 7,700 may not be valid. Whether you anything up to 1 lakh shipment, I think unless they will charge for 1 lakh. So this is also this 1 lakh. There are two options here. 1 lakh is a maximum capacity, and also once you are booking it, then you may have to pay for 1 lakh. So then if it is 1 lakh, the expenditure is going to be for one particular shipment. The expenditure is going to be this into whatever may be the quantity. Then you have to, so 11,000. So 11,000. 1 lakh into 11,000. So that means even if you are going for 7,700, but you have to go for 11,000. So I think the same is the case with the first part. So now again, I am now 0.333. So here I am trying to drag this. Yeah, 0.333. So what happened now? Even it is 33,300, but instead of 3663, I may have to use 11,000. This is what I am trying to say. And it is 6,660. Then also I may have to pay 8,000. And even it is 14,080, I may have to pay 16,000, because it is the expenditure what we are supposed to do that. So 11,000, 8,000, 16,000. So if I take the total, this is 35,000. So, but it is 16,000. It is 14,000. It is 16,000. It is 8,000. It's 40,000. So we have to charge for 40,000. It's 11,000. We have to charge for 1,000. So these are the things we may have to, irrespective of whatever you do, as long as even it is less. If it is more, I think we can go for it. So the shipment is either go for 1 lakh or 2 lakh or 3 lakh. Truck is 40,000, 80,000, 120,000. But whatever quantity you wanted to put, you can put it. But you can only book only for 40,000 or 80,000. You have to pay for 40,000 or 80,000 or 120,000. So these are the constraints we are trying to keep. And now even the cost is also, I think, to simplify our thing, I made holding cost fixed. But the days these are going to arrive, sometimes I may have to calculate on a day-to-day holding cost. Day-to-day holding cost also I may have to calculate. But here I have taken a kind of an average of 1 lakh. Or sometimes, if the inventory cost is going to be cheap, then I plan everything for 12 lakhs. 12 lakhs can be made into 3 components, and 3 lakhs once, and 3 lakhs once, and 6 lakhs once. I think, now I started with a single slide. Now, once you are getting into this analysis, I think, you are getting a lot more questions, lot more issues. That's where I wanted to just emphasize. Things are not that easy. So for which now what I would like to say now, I think before I move to the next topic. So what I'm trying to say here, I would like to, I think, just to avoid any confusion, I take another sheet, paste here. So this is the data I have. This is the data I have. So what now I'm trying to say is, so you have 12 lakhs. Yeah, this data also, let me put it here. let me put it here. Yes. Yeah. Here it is volume per year is here. Here volume per month. Volume per month. Yes. So now we can see this kind of a problem. Now my question is very simple. What could be, for example, if I'm going everything by rail, what will happen? So it is 1 lakh, 11,000. If I go for entire 1 lakh by truck, then what I'm supposed to do? I am supposed to go for 3 shipments, because 40 plus 40 plus 40, 3 shipments. So 3 into 8. So it is the first one is 11,000, because interestingly the shipment capacity is 1 lakh. So within one shipment it is over. But if I go for truck, 40 means I am supposed to have 3 trucks. I cannot have 2.5, either 2 or 3. 3 into 8, I go for 24,000. 24,000. So here it is, sorry, only 11,000. 11,000, because it is only one shipment, 11,000. Here it is 40 means I have to go for 3 shipments. So 2,40,000. So here one shipment cost is 14,080, 16,000. And how many shipments I should go? 16,000, it is 14,080. So about 7 shipments. I have to go for 7 shipments. So this into 7. 98,160. So this is 40,000 is 3. Sorry, one more 0 is missing extra. Yeah. 24,000. Now what I can say, if you go everything by rail, it is 11,000. Everything by truck, 24,000. Everything by air, 98,560. Now this per unit transportation cost is 1 lakh divided by 1 lakh divided by this 11,000. If you put it 9.09. Then it is 4.17. It is 1.001. So 1 lakh you have transported, you incurred 98,560, because here 16,000 and 16,088 is 4,080. 4,080. 4,080 you are multiplied by 7. So 98,560. So 98,560, if you do that, so you have made 7 shipments. So now what is that you are trying to get it here? So here my whole logic is, here it is a rate, these are the days, this is the shipment. Each shipment, how much it. So how many shipments we require? If it is equal 1 lakh by this 1 lakh. So 1. So this 0. 1 lakh by 1 lakh by, sorry, here let me put 1 lakh. While dragging there is some problem. 1 lakh. 1 lakh, I think if you put here 1 lakh. 1 lakh is 1. 6. Actually, it is 3 is fine, because 40. It is 6. Actually, it should be 7. It should be 7. 7. So 1 into 11,011, 3 into 8,024, 7 into 14,000, 98,560. So now you are spending 11,000 rupees to transport 1 lakh. So 1 lakh transport 24,000. To transport 1 lakh 98,000. So now per unit transportation cost is 1 lakh divided by 11,000. This is per unit transportation cost. And here 11,000, sorry, we have to do reverse. Yeah. This divided by, that's where I was wondering, 1 lakh. 1 lakh. 0.11, no issue. And it is 0.24, it is 0.98 because of this shipments. So now I'll stop here, and if I wanted to do further, then how much quantity? Right now, if I go by this option, and what is the 11,000, 24,000, 98,000. So 11,000 is cheap. I can go for rail. But now number of days are 25. So then it is not possible because all customers will not be waiting. So what now I'm making assumption is X1, X2, X3. These are the kinds of, three things I'm going to assume. X1, X2, X3. How much quantity? So now I will say X1 plus X2 plus X3 is equal 1 lakh. Is equal to 1 lakh. So let me say it is 1 lakh. X1 plus X2 plus X3 is equal to 1 lakh. Then here is equal that is the minimize z is equal is X1 and transportation cost per LB 0.11, 0.2, 0.88, X1 into this, X2 into this, X3 into this. This is the kind of objective function. Then also you are trying to have each shipment, how many shipments we are going to have. Finally, what I am trying to do, I am going to formulate a linear programming problem. This is what is called LPP. I am not going to solve because this is only for understanding, I said, because if you wanted to solve it by LPP, I need some more information. With this information, I may not be able to form. But I am only trying to give you how you can proceed with this kind of a problem. So are you able to see the PowerPoint now? Still Excel.
We are able to see the PowerPoint. Yes, sir.
Okay. The next, I think, this is one model I think I have given you, but later if you are interested, you can think of further. The second part is the carrier routing. The carrier routing is a kind of a problem. Here I have cities like this. A, B, A is the origin, J is the destination. And these are all the kinds of distances they are given in the travel time. A to D, 348. A to C, 138. A to B, 90 minutes. B to E, 84 minutes. E to I. So like that, they have given origin to destination. From this origin, I can reach the destination through any method. So with the within the least time. So how do I do that? This is the second model I'm trying to discuss. For which, what we have done here, say for example, A to B, 90. A to B, 90. You can see A to B, it is 90. So A to B, 90. Total cost involved is 90, that is 90 minutes. The nearest node is B, its minimum cost is 90. And finally, you are at AB. This is first part. The second is from A, I can go to B, I can go to C. Right now, I am exploring only these two. I can go to B, I can go to C. A to B or A to C. So what I have done now, A to C or B to C, because finally I have to come to, because already I have traveled A to B. So A to C, A to B already we have seen, A to C and B to C. So when I am saying A to B and B to C, I am going to club these two. That means A to C, 90 plus 66, 156, or if I come here, 138. You can see now. So here it is, 90 plus 66, 156, it is 138. Out of these two, the least is C, it is 138. So its minimum cost is 138. So I am now putting AC. Then the next one is A to D, then C to D, then B to D. You can see now A to D, A to D, A to D, yeah, A to D, A to C, A to B we have completed. Now I am saying A to E, sorry, A to E. So if you look at, A to D, B to E, C to F. C to F is, here C to F, C to F. So here, sorry, A to D, B to E, C to F. So now A to D is 348. A to D is 348. A to D, and you can see 348. So this 348 is given. B to E is A to B plus B to E. Because A to B is already calculated, we are not repeating. So 90 plus 84, 174. C to F. Here it is already A to C is given, and A to C is already calculated, and the C to F it is 138 plus 90. So it is 228. And the nearest node is E, nth nearest node. Then it's the minimum cost out of these three, 174. This 174 I am getting out of B and E. The next I am going for A to D, C to F, here C to F, and E to I. See where is E? E to I. So we have chosen this E to I. C to F, E to I. So like that, A to D, C to D, E to I, F to H. That what you can see in everywhere, A is common, A is origin. So how we are going to reach A to B, A to C, B to C, A to D, B to E, C to F, A to D, C to F, E to I, A to D, C to D, E to I, F to H. Why I am going for D? Because A to B is already over. A to B is already over. Then I started with AD onwards, because here A to B is already over. Now I am coming from this path, and once I say A to B, then A may not be needed, and it goes from B to E. So like that, we have got this. It's a minimum cost 348, 294, 284, 384. So we have got all this, and highest values are given 138, 174. This 138 is to AC, 174 BE, 228 CF. Then 258 EI. Now I am trying to see A to B, B to E, E to I to J. So this is going to be a kind of a connection. So that is A to B, B to E, E to I to J. So the whole idea is to reach A to I, what is the shortest path? It is like our linear programming problem. That is PERT CPM. We have a critical path method. So there we are trying to do that, how to come to A to J. So this is one path. A to J is one path. A to C to F to H to I is one path. And A to B to C. All these permutations and combinations are worked out. But in a systematic manner. In a systematic manner, it has worked out. So whatever is the least, I think we are trying to take. So based on this, we have calculated here. So A to B, B to E, E to I. And this is the distance. So if you take this particular distance, 90 plus 84 plus 84 plus 126. So you are able to reach from this. This is how you can make a carrier route. So that means this is the least kind of a route. And what is the next least? Because this is origin, this is destination. So this is how it is going to reach A to J in the minimum possible time. So this is what we are trying to use this information while identifying the routes. The next one is the routing from multiple points. I think the multiple points are, now we have suppliers A, supplier B, supplier C. These are the three suppliers we have. Here we have a plant 1, plant 2, plant 3. Requirements are given. And this is the transportation cost. It is 4, this is 7, this is 6 per unit transportation cost. 4, 7, 6, 5, 5, 5, 9, 5, 8. So like that, I have some kind of a transportation cost from everywhere to everywhere. Then we are supposed to find out what would be the kind of a quantity to be transported from which source to which destination. Which source to which destination. For which, what I have done, I have taken a problem of transportation. So this is the typical problem. Though the numbers are different and values are different, but I have taken this example. Here S1, S2, S3, S4 sources are there. D1, D2, D3, D4. There are 4 destinations are there. This is the transportation cost. This is the availability. This is the availability. This is availability. And this is kind of requirement. D1, D2, D3, D4. Now we have to supposed to identify from which source to which destination, how much quantity you are supposed to transport. So just I am copying this particular problem here, just like this. Now initially I am assuming 0 quantities we are going to transport. 0 quantities we are going to transport from here. 0 quantities we are going to transport from here. So 0, 0, 0, 0. Now that means the way we are assuming x1, x2, x3, x4. So this is now I'm assuming. So my solution I'm going to get here. Not that everywhere I get some values, but my unknowns are x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, x11, x12, x13, x15, x16, and so on. So there are 4 into 4, 16. 16 unknowns are there. I need to solve these 16 unknowns by using transportation problem. So now I need to have from which source to which destination, how much quantity to be transported. So this is D1, D2, D3, D4, and this is S1, S2, S3, S4. So now my transportation cost is equal some product. I am supposed to multiply this, comma. We are now multiplying the unit cost and the expected transport item. So obviously it is 0. This I am calling as Z. Z is the total cost. So this function is to be minimized. This function is to be minimized because the total transportation cost should be minimum. Now also I know sum of these 4 is equal to 100. First of all, you need to check whether the demand is equal to supply or not. 575. If I select this 4 also, it is 575. So demand is equal to supply. So it is called balanced transportation problem. Otherwise, by adding a row or by adding a column, we need to convert this unbalanced transportation problem into transportation problem. But in this case, it is balanced transportation problem. For example, here instead of 200, it is 150. And this value is, you can see, 575. And if I take this value, it is 525. So 50 is shortage. So I need to create one more column. And here I should put 50. Now if I take this total, 575, right. Now I should put 0, 0, 0, 0. So there's a dummy destination I'm creating. Or if I'm getting here more, here less and here more, then I have to create a dummy source. This is only for your information. That is how we will convert the balanced transportation, unbalanced to balanced. So my next question is, take sum of these 4 items. Sorry, let me keep in the same row so that you will understand. So sum of these 4, that is equal to 0. So like that, I'm extending so that all 4 sums are taken. Obviously, they are zeros, but they should be equal to this. They should be equal to this 100, 150. In the similar way, some of these columns. So here is equal sum of is 4. 0. Obviously, sum of second column 0 is equal to sum of third column 0 is equal to sum of this fourth column 0. So, but they are equal to this. Copy. They are in the rows and I am now trying to copy in columns. So this is transpose. So now all these are equal to this. This is to be minimized by changing these values. Here I am going to get the output, for which I go to data analysis, not data analysis. I have to go to solver. So here they set the objective function as minimization. This value to be minimized. This value to be minimized. It's a minimization. By changing the cells, these cells are supposed to change. Then constraints are add. So the advantage of this Excel solver is you can add all the constraints at one go, and all of them are equal to. Here, say all of them here. 12 to 19. Yeah, say OK. Now it is simplex LP. LP is simplex. LP means linear programming. Make unconstrained variables non-negative. Okay. Okay. Solve. Now, this is what S1 to D1 25, S2 to D1 150, S1 to D2 50, S3 to D4 150, S4 to D3 125. The total is 1900. So this is the total transportation cost. So this is how we should use this solver and try to solve this transportation problem. So now again I'm switching over to my PowerPoint. So here, this is how it is. So supplier, plant, total. They got the solution like this, and the total cost is given like this. So whatever 1900 I got, this is the solution for the problem what we have shown. So this is the transportation problem linear program. TRAN, TRAN, LP, linear program. So this is the linear programming we have done like this, and we got the solution like this. This is the kind of a third one. The first one is I have taken a simple Excel sheet, how to identify, and for which I have given you some approaches with provided data we should have done. Second one is the origin to destination by looking at the nearest neighbor. How do we do that routing problem? The third one is we have done about the transportation LP. So this is the third kind of a technique. The next one you can see routing with a coincident origin or a destination point. I think here there is a depot and we have these points, and one vehicle is supposed to travel all these things. So now what is happening now? Which goes from here. But instead, if it goes here, it will minimize the distance. This is called good routing. No path crossing. Here the two paths are crossing. That means unnecessarily from here you're going here, coming down and going here. So typical of many single truck routing problems from a single depot. So mathematically complex problems to solve efficiently. However, good routes can be found by forming a route pattern where the path do not cross 3/4 a teardrop pattern. So it is not like a teardrop pattern, looking like that. It is here. So this is now I can compare. This is like our assignment problem. Whatever we have done is like traveling salesman problem. Traveling salesman problem also we try to do the same. That means there are all cities. The salesman starts here, touch all the cities and come to the origin. So this is how it is. So depot, it starts from depot, it ends with depot. So for this also, I have taken this traveling salesman problem. So the same example. So the distances you can see A, B, C, D, E and A, B, C, D, E, and somebody has to travel A, B, C, D, E, A, B, C, D, E, and A to A is not possible to travel. That's where I put X. A to A, B to B, C to C, D to D, E to E. These are all kinds of X. So now here 4, 7. These are the distances. A to B 4, A to C 7, A to D 3, A to E 4, B to A 4, B to C 6, B to D 3. Now I would like to find out a kind of a optimal route. So, but the system will not understand what is X. System will understand only the value. But if I keep 0, 0, 0, it will simply say A to A, B to B, C to C, D to D, because that is the least cost. I am trying to minimize. So since I take some large number, 100 and 100, so that means it is impossible to travel from same source to same destination. This is my assumption. 100, 100, 100. Yes. So now, the way I have done my transportation problem, I am doing the assignment problem also here, but here I will put all zeros. Right now I put all zeros. So that means here I am converting this problem into a transportation problem. But the problem is it is how one has to move A to B. Somebody goes from B to somebody should come to A. B to C, for example, not A. If you come to A, it would be a loop which is forming and somebody is not moving from there. And A to B to some D, D to some E, E to some A, whatever, some secret. There are several possible combinations are there. But here what I am now assuming is here only one, and if it is going to a particular city, it is 1, otherwise 0. So that means from A in this particular row, I have to only have one single one, all remaining are zeros. So it should be 1. That means, it should be 1, and all others are zeros. There should be at 1, and 1 means that is going from that to that is connected, remaining are zeros. In the similar way, here also I am connecting 1 and 1, 1. So here, the way I have done here earlier is sum product again. Sum product, whatever I have done earlier. So this part, comma, this part. So I know that, in this entire answer, I may get zeros and ones. I get E10 to, yeah, sorry, E10 to E5 to I9. So there is a mismatch. Okay. Right. 0. This is to be minimized. This is my objective function. This is my objective function. This is my objective function. This is minimize. Minimize. This is minimize. Okay, fine. The next one is, as I told you, sum of all these equal to 1, because there should be only one assignment in entire row. Sum of this 4 5 is equal to 1. This sum I can drag up to 5. If I click the last one, this is the last row. So this 1 will continue for all. Yeah, 1, 1, 1. This is, now it is because in this row or column, any row or any column, I should have only 1. So that means one city can be assigned to another city only. Next, not too many cities, because now we are saying they have to travel only once. In the similar way, the way I have done earlier, sum is column is equal to sum, second column is equal to sum, third column is equal to sum, fourth column is equal to sum. So these are the things we have. And now this is the left side, this is the right side, and this is the function to be minimized. Go to data analysis, sorry, not data analysis, solver. This function K13 is a minimization. By changing the values, these values are supposed to change. Adding the constraints, this is the left hand side equal to, this is right hand side. Say OK. This is simplex LP, non-negative, solve. Okay. Now it is the sequence I got. What it says, we should see now. It says A2, this is a D. B2, B. B2, again A. That is whatever is given. Actually, it's not supposed to, because A, B, B, A means, you are ignoring C and E. From A, B to A. Then instead of B to A, now you go to the data and you see from B what is the least. 4, 6, 3, 4. 4, 6, 3, 4. So A, because 4 is the least, D is already over. So 4 you cannot go. 3. The next option is E. You can go to E. That is the least. From E, you can go to C. From C, though it has said E, there is no option. You can go to A. You can go to A. This is how I think, because A to D, no problem. D to B, no problem. From B, it is saying A. I cannot go to A. Then I say from B to A, it is not possible. The next possibility is 3, least 3. D is already done. So next option is only 4. So I can go to 4. That is E. And E to C, no issue. We have taken that. C, there is no other option. I have to go to A. Now, A to D, it is 3. Okay. Then D to B, it is also 3. B to E, it is 4. Okay. E to C, yes, E to C. C to A, yeah, though it is 7, fine. So 3 plus 4, 7 plus 7, 14 plus 3, 17 plus 5, 22. So this is the path. So this is the kind of a technique, whatever we use in traveling salesman. We use the same technique here. So here, there's all things are there, and it's like a loop. So by using that kind of a technique, we can find out. This is the traveling salesman problem, the way we use. The next one is multi-vehicle routing and scheduling. Multi-vehicle routing and scheduling. So a problem similar to the single vehicle routing problem. So here earlier one is single vehicle routing problem, but here I am using multiple vehicles because single vehicle may take some time. Then I have to use multiple vehicles. So then I have 2 kinds of routes. So the number of restrictions placed on the problem, chief among these are a mixture of vehicles with different capacities. I think the capacity of the vehicle can be same or different. Time windows on the stops. So how much time it will take. Pickups combined with deliveries. Total travel time for a vehicle. So this is how the information is given. So now you can see these are the kinds of, this is the depot. And these are all kinds of my places. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So then I have 2 vehicles. I have 2 vehicles. So there's 2 vehicles, one has done like this, one has done like this. So from here, one is gone like this, come back. One has gone like this, come back. So this is a weak clustering. But if you do clustering of this way, from here, I think one has to complete this and one has to complete this, so that these distances are going to be lesser than these distances. That is where this is going to be a better clustering. So I think, the last part, I'm going to show that, and yeah. So this is like, a vehicle routing problem. So just I'm only showing, I might not be able to solve here right now. So this is the origin, depot. These are all my destinations, 1, 2, 3, 4, 5, 6. And I have 2 trucks. Each capacity is 10 per truck. Total I have 4, 6, 3, 2, 3, 2. That is the requirement. And 1 I require 4, 6 I require 2, I require 6, 3 I require 3, 4 I require 2, 5 I require 3, 6 I require 2. From here, if it is like, single vehicle problem, the way we have done traveling salesman problem, these are the distances. 1 to 4, 2 to 3, and 1 to 2 is 18, and 2 to 1 is also 18. So that's where, we have not written. We have not written this. So here, depot to depot, yeah. It is depot to depot. Depot also I am now bringing here. So this 1, 2, 3, 4, 5, 6 and depot. So all 7. So this is the matrix. So I would have gone for a traveling salesman problem. But in this case, what I am trying to look at is, I am going for a kind of a 2 vehicle problem. 2 vehicle problem. 2 vehicle problem means I have total requirement 20. Each vehicle can have a capacity of 10. 2 trucks I have. Now you see how I am going to do that. See, for example, yeah. I'll say, for example, 1 to 2 here, 1 to 2, 2 to 1, 1 to 6, 6 to 1. This is, I'm considering is 1 truck is going to do all these 3. Now I will take another truck. I will take this kind of a truck. I will take this kind of a truck. It will go like this. It will come like this. It will come like this. It will come like this. Just I am only making some kind of assumption how it works. So now earlier I had 1 truck. Now I have 2 trucks. So now the first one is, if I go for this distance, what will happen? This distance, what will happen? So depot to 2, 18. Depot to 2, 18. Depot to 2, 18. Depot to 2 here, 18. 2 to 1. 2 to 1 means 1 to 2, 18. I think somewhere, we have gone. Yeah, depot to here. Depot to 2 is 18. Depot to 1 to 2, 22. 18 plus 22 here, 1 to 2. And 1 to 6 is 18. And depot to 6, 19. So you add everything, I'll get some distance. In the similar way for this, I'll get some distance. But my problem is, I have only 2 trucks. One truck is here, one truck is here. But if I take 1 to 6, 1 is 6, 2 is 6, 6 plus 4, 10, and 6 is 2, 12. So it is beyond 1 truck capacity. So then I need to change my combination. Instead of this, now I will probably do another kind of a mode. What is that another kind of a mode? I can say, for example, here, like this, like this, like this, like this. This is one mode. This is another. This is the top vehicle. Then it is 1, 2, 3 top. So, but if you take 1, 2, 3, it is 4, 6 plus 3, 13. And it is 6. Remaining is 2 plus 3 plus 2. It is 7. So it is also not working out. So then, and also accordingly, I need to calculate the distances. I am now looking at the load. I am also looking at the distance. Okay. Now what do I do now? Is there any other way? So now, for example, if you look at 6 plus 3 plus 2, 11. 4 plus 6, 10. So 1 and 2. So now the next option is this. The next option is this. That is like this. So because 1 and 2, 4 and 6, 10. And this is like this. The remaining is 3 plus 2 plus 3 plus 2. It is 10, it is 10. Now you calculate the distance, you calculate this distance. Now how it works. Or sometimes, if you suggest there will be a third vehicle and the distance is going to be minimized because I'm going to calculate the cost of my transport based on the distance traveled. So if you think, that is going to be too much, and I think hiding the third vehicle is going to be cheaper, probably you can also explore that possibility. So like that, you are trying to do this kind of, the multi-vehicle routing problems. How it is, this is kind of a clustering we should be doing, for which actually I made simplified, but yeah, this is what it is. These are all kinds of places we have, and this is how it is going to be clustered. So for which we use a lot of mathematical modeling, but I'm not getting into too much of mathematical modeling. So then building routes beginning with a farther stop from the depot, the stop sequence of a route should be form a teardrop pattern. The most efficient routes are built using the largest vehicles available first. I think, there is a vehicle which a higher capacity. For example, take the earlier example. So I have got 10-10. Instead of 10-10, I would like to have 8 and 12. So then that would have been more economical for me than 10 and 10. I think that could be a suggestion. That can be an outcome of my analysis. Pickups should be mixed into delivery routes rather than assigned to the end of the routes. I think instead of straight away getting into pickup should be mixed into delivery routes. Pickup also should happen in the delivery route. Sometimes we have reverse logistics. We try to take back certain things. So that also we can, but whatever you are taking back, that should be equal to whatever you have dumped or less than that. Otherwise, your vehicle capacity is a problem. A stop that is greatly removed from a route cluster is a good candidate for an alternate means of delivery. Narrow stop time window restrictions should be avoided. Okay. So like that, we have different kinds of methods. This is another kind of a technique. The depot is here and we have all these locations. And how do we go for the stop volume location? Now you can see this. Now there are the three kinds of vehicles: route 1, route 2, route 3, and how it is being done. So route 1, 10,000, 8,000, and 2,000. And distances also they are not given, but with the distances we can find out. They're only given the quantity. Sometimes distance, sometimes load. Load alone, distance alone, load and distance together. And 1 vehicle, 2 vehicles, 3 vehicles, 4 vehicles. Based on that, we are going to make those many clusters. Then I think it's 1-4. This is another route sequencing problem. I think I'll stop here. Actually, I have about 60 slides, but the transportation itself required 2 hours, but we said transportation and distribution. But the distribution also, I think now we have covered something as part of transportation, how the things are being distributed. So I'll stop here. Now, had it been a face-to-face class, I would have got a lot of interaction and so on, but now it's very challenging for me to interact with the participants. But hope you enjoyed this 2-hour session. And I stop here. And if you have any quick questions, I would like to answer.
Sir?
Yes, please.
Thank you so much, sir. It was you explained the concepts very clearly.
Yeah.
I think it requires some more time for us to do all this. Sir, I have one doubt. What is fleet management, sir?
What is it?
Fleet management.
Fleet, FLE.
Yes, FLEET.
The fleet management is, when you have multiple transports, multiple modes of transport. For example, so many vehicles. How you are going to do that? In a bus depot, we have multiple vehicles. How you are going to do that? So their timings, their arrival time, their departure time, their loads, their calculations, and so on. That is like, for example, the flights and others also, they keep on speaking about the fleet management systems.
Okay.
Yeah.
Thank you, sir.
Thank you.
Any question from the participants? So today we have covered almost everything related to transportation and distribution management, starting from difference between logistics and transportation. We moved on to transport modes, risk management in transportation. Sir has told different examples in modes and service selection. Also, we have solved different problems related to optimization of the transportation.
Yeah.
You have to use one vehicle as well as 2 vehicles, different way of transporting the goods from one location to other location using solver. Sir has told means the techniques of solving the transportation problems. So these are all important for us, sir. Participants are requested if you have any question, if you have any doubt.
Okay. Sir, one last question.
Please.
This packaging and containerization is same, sir?
So packaging means, you are packing with something. Container means, when you are taking the fluids and liquids. So that you use in a container. The package means the individual item package.
Okay.
Yeah.
So thank you, sir.
Okay. Anything else?
I think no more questions, sir.
Thank you. Thank you.
Thank you, sir. Sir, thank you for your valuable deliberation.
Thank you. Thank you. Yeah.
Thank you.
Thank you. Thank you. Can I leave the session?
Yes, sir. Yes.
Okay. Thank you. Bye.